When your set of directions say to solve the quadratic by factoring, it's much different than just factoring. There is extra steps involved, but it's extremely important that the first thing you do is to put your quadratic equation into standard form. Remember, that means it's ax squared plus bx plus c equals 0. That equals 0 is extremely important. You cannot solve this by factoring without first getting your quadratic equation equal to 0. In our first example, it already is equal to 0. So what I'm going to do is focus on the expression on the left side of my equation. And I want to factor that expression. So just like we were working on earlier, I put the negative 6 up top, the negative 5 underneath. I know that a positive 1 times a negative 6 will multiply to negative 6 and add to negative 5. I factor it exactly like I did before. That's going to be an x plus 1. That's going to be an x minus 6. The last step I do here is to bring this all the way back down after I've factored. And it's equal to 0. What this is telling me is that if I take x plus 1, multiply it by x minus 6, my product is going to be 0. The key that we have to think about there is, no matter what it is, if I'm multiplying two things together, and I know my product is 0, like I am in this case, one of these two things must equal 0. That's our zero product property. We call it ZPP, the zero product property. It states that this x plus 1 has to equal 0, or this, one of our two factors, x minus 6, has to equal 0. So my last step would be to solve each one of these equations separately, because I have two different equations here. I'd subtract 1 from both sides and get x equals negative 1, or I add 6 to both sides here and get x equals positive 6. Those are the solutions to this quadratic equation by factoring. If you recall, we had two solutions when we were solving by graphing. We'd have two solutions if we solved with the quadratic formula. We would have two solutions if we solved by taking square roots of both sides. We can also have two solutions when we use the solve by factoring method, and this is going to be how we would do that. The second one is only slightly different. The major difference is it's not equal to 0 right now, so I have to put it in standard form first. I'm going to add 35 to both sides. Let's make sure we do 35. I get x squared minus 12x plus 35 equals 0. Now I'm going to factor the expression on the left, which means something that multiplies to 35 and adds to negative 12. That is a negative 5 and a negative 7. I write my factors, x minus 5 times x minus 7, and I bring down my equals 0 and apply the zero product property. X minus 5 equals 0, or x minus 7 equals 0. So when I add 5 to both sides here, add 7 to both sides here, I get x equals 5 or x equals 7. And those are my solutions. The last one, and this is a little bit tricky. This is really only going to work for us when a is equal to 1. Not negative 1 though. So on this last one, I could subtract the x squared from both sides, and I'd get 0 equals negative x squared minus 3x plus 28. But I don't want this to be negative in front of my x squared. Our method that we're using right now will only work when I have a positive 1x squared. So instead of doing these steps, let's move everything to the side where x squared will be positive, which means I'll add 3x to both sides and subtract 28 from both sides. So my equation would be x squared plus 3x minus 28 equals 0. Now when I go to factor the expression on the left, I need something that will multiply to negative 28 and at the same time add to positive 3. That winds up being a positive 4. Nope, make that a negative 4 and a positive 7. So my factors are x minus 4 times x plus 7. And just like before, it has an equals 0. I have to bring that down as an equals 0 and use the zero product property. X minus 4 equals 0, or x plus 7 equals 0. Last but not least, solve both. Add 4 to both sides here, subtract 7 to both sides here, and I get x equals 4 or x equals negative 7.